Hello, this is Strategy Miscellany, and this is our first interplanetary probe design, the Dunorbiter 2. And basically, the idea is that this is going to get a probe to Duna. We've got the lifting stage, gets us basically into orbit. We've got this stage, which is kind of the interplanetary transfer stage, kicks us out into an interplanetary transfer, gets us on a course to Duna. Then we cut off to this stage. We use this for circularization, and ideally we'll use it to also go to Duna's moon Ike and do science on all this here. It has 6 of these antennae here, which hopefully should be enough to send data home. Got the reaction control wheels, the solar panels, the science equipment, and so it's not going to land anywhere, but it's going to be our first venture interplanetary. So it's a beautiful morning day for a launch. Let's give it a go. See the morning sun out over the ocean. Get everything ready, and 3, 2, 1, ignition. Goes roaring upwards. We've got 4 mainsail engines. We've got a central core here with extra fuel. We've got 4 of these large thoroughbred solid fuel boosters. And we're 1,000 meters up. It's time to start heeling over a little bit. See the space center below us. See the island in the distance there, or island chain in the distance there. Get us turned over a little bit more. Got to be careful you don't tip the whole thing over. And you can see as we burn down, we're getting pretty good thrust to weight ratio here now. 10 kilometers up. Starting to heel over. Get us over to 45 degrees. And any second now, it'll be time to detach these solid rocket boosters. And for that, we align ourselves with our thrust vector and let them go. Farewell, SRBs. Apoapsis is getting high enough so we can start heeling over all the way as we escape most of the atmosphere. And I'll cut back once we're in orbit. So we've reached Apoapsis, 300 kilometers up. And now we do our little circularization burn with this stage. See the periapsis coming up. And pretty shortly, we should be circularizing. All right, that's close enough to circular. Let's get this ship ready for interplanetary travel. So we'll put out all the solars and all the antennae, and then we can start plotting a course to Duna. The ship all in configuration for interplanetary flight. Go to the map here. Now what we want to do is we want to go from the outside edge of Kerbin because we're flying further out. And because it takes a little bit to accelerate, we're going to start from a little bit behind. So we can basically be shot straight out into an orbit higher than Kerbin's. In fact, I should even start a little further back than that, like this here. Or even maybe like this. You can see there's our path versus Kerbin, and if we zoom out, we can see that we are just about crossing Duna's orbit there. Set them as a target, and you can see they're a little bit ahead of us. So what we need to do to fix that is we need to get to them a little bit faster. And the best way to do that, the reason that is because I just kind of eyeballed the degrees, and I waited a little bit too long, or maybe didn't wait long enough. Regardless, we can correct it here without too much difficulty. So now we need a little bit more delta V because we're going at kind of an angle. You can see we're moving the periapsis inside Kerbin's orbit. And now those are a lot closer together. Let's even take it a little further around Kerbin. Extend out again. All right, and that's close enough. We should be able to do a course correction maneuver. Well, let's get it a little closer here if we can. Go like that. We can see now we're really starting to kind of cut the corner there a little bit. I can also kind of do this alignment to get things closer. Burn at an angle a little bit. Okay, and that's close enough that we can do the rest with a course correction adjustment when we get closer. So we warp to our burn node. Oh, I'm going to cancel the warp a little bit early because this is going to take 4 minutes to do the burn. So I want to start about 2 minutes beforehand. Also, because it takes a little bit of time to do the burn, it'll be a little bit inaccurate from what our node shows, so we'll have to do a course correction. But we have plenty of fuel here. You can see we have more than twice the fuel in this transfer stage that we need for this burn. So we're quite able to... Oops. I just deleted my maneuver node by mistake. All right, let's put it back in. I think it was about here. All right, there we go. 4 minutes of burn. I better align myself with the point. Now that the chip's a little lighter, we can actually use the reaction control systems to move it around without too much trouble. And once we're aligned on, we can start the burn. Full power. Get ourselves aligned with the target node, or the target vector. And that pink kind of shows where Duna is relative to us. So we're not quite burning straight for it because we have to adjust for all sorts of things. And you can see if we go here, our apoapsis widening. First slowly, but it will begin to accelerate as it gets further out. And we're approaching the target point. Got about 3 minutes left in our burn. All right, I will cut back when we are closer to the end of our burn. So as you can see, our apoapsis is just passing the moon. In fact, right now we would be going through its gravity well. But as this gets further out, we should no longer intersect with the moon's trajectory here. Yep, passing Minmus. And we are escaping the Kerbal system. We just need to get our vector aligned with the proper escape vector here. As we burn through our last 30 seconds of this burn. And yeah, should still have plenty of delta V to do maneuvers with this transfer stage for course corrections and the like. My plan is to crash the transfer stage into Duna and then properly circularize with this last stage, although we may be able to do a lot of the maneuvering with this transfer stage, in which case we can probably use this maneuvering stage to do a little bit more than we would otherwise be able to. All right, let's see how our trajectory looks. First, let's go out. So let's escape the Kerbal system here. You can see Kerbal falling away behind us. As we head out into deep space. There's the moon, little eclipse. Don't think we'll see Minmus. I think it's at another part of its orbit. Pretty quick, we should be reaching the escape point of the trajectory. Oh, we still got a little ways. Let's speed this up. All right, we are now in solar orbit. And you can see we were actually pretty good there, only 225,000 kilometers away. So we'll just have to do a little fiddling, course correction. And the best place to do that, I think, is about kind of halfway in your orbit. It will take us basically a full Kerbal year, or almost a full Kerbal year anyway, to do this transfer to Duna. So let's start moving things along. And you can see we now have a capture in the Duna system. Just have to fine tune it a little bit. And we can do more fine tuning when we get closer, of course, too. Okay, a little bit of vertical fine tuning. Yeah, now we should be about 10,000 clicks away from Duna at our closest approach. 7,000 clicks. All right, that's enough for now. So now what we're going to do is go on a long journey to the next transfer point. Get up to 100,000 times speed and start our slow orbit. And thankfully, right now, we still have 100% signal strength. That's my kind of one concern with this mission is, will we actually have the antennae strength to communicate back home? Also, if we end up eclipsed by Kerbin, we could lose control of our craft temporarily. Or eclipsed by Duna from Kerbin. But for now, signal strength is steady at 100%. And we are approaching the course correction point. All right. Align ourselves for the course correction. And do the little burn. Now, if I were going way into the outer solar system, I would need something besides solar panels to provide power, because they get weaker as you get farther away from the sun, of course. But for now, these four should be plenty. I don't have that much that consumes power on this craft. You know, when I rotate, sure, but I can always charge up to do that. And then the probe core consumes just a little bit of electricity. Science experiments consume electricity to transmit, but again, you can sort of wait and charge up. I've got yeah, 600 units of battery power on this craft, so that's decent. All right, let's see what this looks like. So we now have periapsis at about 5,800 clicks above Duna, and let's start heading for the intersection point. You can see us kind of between the two planets here. This probe will probably lose signal with Kerbin at points in the Kerbin Duna uh, relationship. At points when Kerbin is far away from Duna, it might pose a problem. But I think I should have enough signal strength to control the probe at the point when we arrive. I mean, as you can see, Kerbin is pulling away. We're starting to lose signal strength. We're down to 93%. But we're just about to get into Duna's sphere here. It's about 40 Kerbin days away. Let's see. Pretty soon we need to slow down time. Let me see if I can see Duna from my ship anywhere here. Not that I can find. Slow down a little bit more as we approach the sphere of influence change. And you can see we're now in sort of a crossing vector with Duna here. Now the first thing I'm going to do is, because I have this extra fuel in my transfer stage, I'm going to use some of it to just decelerate here. Then what I think I want to do, what kind of orbit do I want? I mean, a polar orbit would be nice for seeing the whole planet, but equatorial would be easier to get an intersection with Ike here. I should be able to swing it from a polar orbit, though. So let's start working out a course correction. Pull the ship in, pull the ship up, pull the ship in, decelerate the ship. That's a good start. So let's warp to the time point. And you can see Duna and Ike in the distance there. Beautiful. Do our little deceleration and realignment burn here. Then it's time to start doing some science. Transmit the data off that. And let's start some of the other scientific instruments here. Temperature and pressure, not that they make a whole lot of sense out here. And let's see how our electric charge is doing. Give that a minute to recharge. Then we'll do one of the big science modules. All right, beautiful. Now let's do another trajectory adjustment. Right at periapsis, maybe. See if we can circularize on this tank. Yes, we absolutely can. I'm going to leave the apoapsis high so that we can drop the periapsis on this last bit to send it crashing down to Duna, and then properly circularize with our circularization stage. But let's warp to the next point. See the whole system moving below us. Real nice. Now about 300,000 meters above the northern ice cap, we can do our circularization burn. Nice atmosphere effects and everything. Very cool. And yeah, you can see the Duna system is different from the real world Mars in a couple ways. Number one, the ice caps are much larger than on the real Mars. And number two, it has an almost Luna-esque moon over here. You know, the same way that Luna relates to Earth. It's got a big moon that relates to Duna in the same way, as opposed to the real Mars that has two little teeny moons. So we are circularized. And then the next step is to drop off the big tank. Keep space clean to crash all the stuff into the big planets. Or sorry, to crash your extra stages into other planets. So we'll do that, and then we'll get ourselves into a close-in orbit over Duna with this machine. Hopefully, we should be with this polar orbit. We shouldn't have to deal as much. You can see there we're cut off from probe control from home because Duna is eclipsing us. And now we're back into it. Heading out to sort of a distant, hovering over it here. You can see there it is above us. Kind of a weird angle to see. Ooh, look at that weather effect. There's some kind of storm going on. Cool. All right, time to... There is actually extra delta V still in the transfer stage, but it's time to abandon the transfer stage. Do our little burn here. Drop the transfer stage into Duna. And now we have our final probe stage here. What we're going to do, going to let that stage get out of our way first. And then we are going to fix our orbit here so that we're not crashing into the planet. But I do want to stay fairly high, fairly low above it. Like just, you know, something like 160 clicks up would be good. Now we can really swing this thing around, you can see. Doesn't have much weight on it anymore. And it's got these little engines that are quite loud for their size. And now we just need to circularize at the other side of Duna. All right, that looks pretty good. Let's do our little orbit around here and get in close. See us coming in over the pole again. We should be in close enough to do the close-in science now. Hopefully we're not cut off from contact at the node here. It doesn't appear we are. So we'll do the little burn. Spare you the noise by zooming out a little bit here. So what I'm going to try, if I can, is if I have enough delta V, I'm going to try and land this thing on Ike. That was not in the intended mission profile, but I think it would be a cool achievement if possible. And I did maybe overbuild it a little bit for... Uh-oh. Well, this is a problem. So you can see we just went into the Duna region where we can't see ourselves. Or sorry, where we can't see Kerbal. And that means the engines are stuck on. Which means that we are turning ourselves into a impact trajectory with Duna quite quickly. What I think we'll actually end up doing is reversing the whole orbit and then getting out of the zone where we have no probe control. But I don't know for sure. I should have looked at that more carefully. But that's why in the long run I'll want like some sort of ComSat in a high polar orbit over Duna so that it can act as a relay for probes like this. And of course, if this were a crewed mission, we wouldn't have any sort of problems like this. But we may end up doing an unplanned atmospheric entry, depending on how this goes. As you can see, we're starting to basically get pretty close to falling straight down here. Good news is we're still a little ways above the atmosphere. And we do still have a ton of delta V. I think we're going to have to give up on that plan of visiting Ike. But I think I can, fingers crossed, get this into an orbit that will not doom us all. Problem is, I have to get back to where you can see there's Kerbal. You can see the Kerbal Space Center artificially showing there. And right now I'm basically having to look right through the planet, which means I have no communication. Alright, I'm going to put this on physics warp to speed this up a little bit and see what happens. Orbit is starting to go the other way. Question is, do I have sufficient delta V to avoid this from just crashing into the surface? You can see the periapsis is declining. I don't think it's declining fast enough, though. I think we might be screwed. Because any minute we should be reaching atmosphere. And we are basically on a straight line collision course with the Dunan surface there. Well, that's how things go sometimes. You can see we are in atmosphere now. Out of fuel, no control. That's space travel for you. I should have been more careful plotting that node. So here you can see we're entering the thicker atmosphere. It's ripping off our solar panels and our antennae. And unfortunately, we're over the night side, so I don't have as many pretty pictures to show you. There's a cloud layer coming up. Looks like it's not great for my graphics card to have that cloud layer there. Maybe I'll try looking up, see if that helps it. We're about 5,000 meters above the Dunan surface. And as you can see at this point, collision is basically inevitable. Well, not basically, collision is inevitable. Looks like we're going to land in kind of this valley region here. In the soup. If I'd put parachutes on this thing, it might actually survive the landing. Although it's had all its antennae and solar panels ripped off, so wouldn't be able to do much. I think we should be getting out of the cloud layer soon. We must be soon. We're only 800 meters up. I guess the clouds on Duna are quite low. Have to worry about that when we're landing in the future. When we're doing actually planned landings. And kaboom. Landed on the surface. Well, landed. All right, not exactly what you'd call a great success, but, well, we made it to the planet. We got a little bit of data back. Let's go back to the Space Center, see if we have anything from that science sufficient to unlock another node. All right, so here we are, nighttime on Kerbin. Unfortunately, we do not have enough to get a full one of the more expensive nodes here. So what we'll have to do is just get one of the cheaper ones here. Like this one here with some of these specialized control elements. And the next step is going to be we're going to build a probe to land on Eve. And have a probe to orbit Eve and then a little landing module. The nice thing with landing on Eve is if you don't have to get back, it's quite easy because the atmosphere is extremely thick and will slow you down quite a bit with just one little parachute. So We'll build an orbiter module, we'll build a probe module, and we'll get some more scientific research done that way. After that, I think we'll take a little break from interplanetary missions to set up a research station on the moon with a large Kerbal mission done probably in the Apollo style with docking the capsule together in moon orbit, and maybe experiment with planes a little bit. But actually, I think after we do that science space, it'll be time to, well, probably to do a successful lander mission to Duna. And then after that, it'll be time to start thinking about Kerbal missions to those places and probes to further outer planets. So, thank you very much for watching and have a great day.